Good morning, folks. So today we have a very exciting topic to discuss, and these are some of the kind of questions and conundrums that we're going to face more about as we have autonomous systems and AI, making decisions on our behalf. So the topic for today's discussion is model decision making for autonomous systems. And so what autonomous systems basically are machine learning based or AI based decision systems, which are making decisions on our behalf, maybe with our consent or maybe without our knowledge too. But the key thing that I'm going to talk about today is these decisions are life and death decisions. And the question then is, what happens when the autonomous system makes an incorrect or an adverse or a risky decision that could lead to something like a choice that we wouldn't want to make or a choice that is fatal? So how do we actually now try to reason about this? And so today I'm going to talk about what kind of research we do within this area, and also what kind of role discussions and play in going through these moral dilemmas as we are building these systems. These are the choices that engineers need to make while making these engineered systems that are working on our behalf. So by introduction, I just want to talk about where I come from in this world and where we are heading to. So I serve as the director for the X Lab, which is the Safe Autonomous Systems Lab in the Penn Engineering Complex at the intersection of electrical engineering, computer science, mechanical engineering. I also serve as the director for Penn for Safety 21, which is a $20 million Department of Transportation, National University Transportation Center, where we are building these kind of autonomous vehicles and autonomous decision systems. And we need to make sure that these are safe for the public. I also serve on the boards of many different foundations that are nonprofit foundations that build open source software that drive, full-scale autonomous vehicles like robotaxis in Japan, buses in Turkey, or cargo systems in Estonia or other parts of the world. And through this, we are really building the research foundations as part of the Autoware Foundation or the Autoware Centers of Excellence. So there are many different companies that are part of this decision-making too. And we really need to figure out how can they all have their selfish motivations and their but work collaboratively, as these problems are very complex. And we also have a lot of outreach for students with the autonomous racing community, where there are over 80 universities that use our racing platforms and our software and compete regularly in different conferences. But enough about me. Let's get back to our very exciting topic for today, is on moral decision making for autonomous systems. And I'm going to try to take one angle from the AI or machine learning side of things, and on the other angle is on the ethical systems. And the challenge that we as engineers face is that we really have this dialogue or this discussion, and that's what we need to bridge over here. So let's see this in the context of something that you might have heard a lot about: autonomous driving. It has been, in the news, and it's been in a lot of buzz for the last, decade or so. There's been a lot of investments there. There are self-driving cars like now Tesla. You just give it the address and say, let's go. And then it's going to drive you all the way to your destination. The good news is that, now, the Tesla is, Elon Musk says, hey, Penn students, I'm a former Penn alum, I'm going to give you guys a free Tesla. So how many of y'all in the audience now, raise your hands if you would want to have that free Tesla, right? And of course, Elon Musk, he doesn't expect Penn students to be any less. He wants you to use this autopilot system that he's built up so well, right? As you can see, it's driving along so well. So how many of y'all would want the free Tesla and will have to drive it in autonomous, mode, the autopilot mode, right? So raise your hands. All right, look around, see each other. And obviously, this is a trick question, right? Where's the fun in that? So let's look at, now, what are the engineering goals as we sort of go through this, right? So, well, we want to make sure that, this system can drive anywhere, anytime, any sort of road conditions. They have to be safe, otherwise nobody's going to buy them. If you introduce 500 of these self-driving cars in West Philly and Center City, we don't want them to crash into us as pedestrians. And so then, we came to this question, that, okay, fine, we are building a lot of this technology at Penn in different places. And, why does, an engineering student need to be, who's building these autonomous systems need to consider ethics? I mean, we are going to build these systems. They get paid really well in the Bay Area. So let's take a look at what's happening, today, right? So this is an example of 2016. There's a self-driving Tesla, and it just bumps into this vehicle, right? So the other car just moved on the side like you and me would. And so no big deal, and so then this moves on to the next level. This is in China now, I think around same time, maybe around 2017, 2018. And this is going at about 55 miles per hour. And then you can see there's a street cleaner here, and it just crashes head on. And a 23-year-old, dies on the spot over here. Now, the goal here is not to show you something, that is, alarmist, but or to beat up on Tesla per se, but to show that, well, these, problems now, again, in 2018, you can see it's trying to prevent it from veering off the highway. This is the car that is out there that has most of the examples, right? So we're not necessarily just picking on this one company. We're picking on this concept. Now the machine is making decisions on your behalf. You're not using your hands or your brains or your feet to drive the car, and you relinquish control, and you actually consent to that. And then, but now when things go wrong, how do we start to think about them? How do we start to reason about, where does the blame lie? What is the cause and effect of this? Now, how do we actually now look at, who is responsible in this equation like that, right? And then these recalls continue happening, and and I think so that's why this is a pretty supercharged place, but it's in everyday life like that, right? So it's not cars are, safety is the number one thing that sells these cars. Tesla sells still very well, right? It's one of the best selling vehicles worldwide, actually, not just in the US. And so we are not talking about Tesla per se here. We're talking about what happens when these systems go wrong, right? So, like, for example, and this is a case with Uber now, where we have this safety driver, and let's take a look at what's happening over here, right? So, so this is a safety driver driving down, and there's a pedestrian crossing there, and this Uber is, now going in, self-driving mode. And it hits the pedestrian and actually kills this pedestrian back in 2018. And so the question then is, well, who is responsible, right? Safety driver is supposed to be responsible, but the safety driver has some expectations of the vehicle, and should the car be responsible? And so I think now we start to think about, who is responsible, right? So if you can think about it as, who are the players right now over here? So just take a moment and think about it. We saw the safety driver. So what was she doing? But think about it from the safety driver's context. She's like maybe slightly better paid than a minimum wage person. But if you screw up in your job, you go to jail for, many, many years. Now, is that a fair decision or a fair, kind of job offer to make? Versus say, like now the safety driver has some kind of expectation. Uber has to tell them that, look, this car will drive in this manner. So Uber is another, stakeholder over here, and they are designing the software, and then they say, well, the reason we have the safety drivers because if the software doesn't do well, they should become alert, and they should intervene. Then they call that a disengagement. But here the software is, has to tell the safety driver, hey, I'm not able to make a choice right over here. And so as we go through this now, you can say, okay, let's drill down now. Okay, well, there's So Uber is the autonomy manufacturer in this case, right? Um, then there is the designer, the programmer who designed this computer vision algorithm that was supposed to identify this person, whether it is with the lasers or with the cameras or with the radar system. And they are supposed to say, well, there is somebody there is something there, and we should hit the brakes, like that, right? But then the computer vision person will say, well, I didn't know it's going to be in exactly this scenario. And, I mean, it's supposed to be working generally very good. And so they say, well, should I be blamed for everything over here? Uh, then you could say, well, what about the computer that provided the data set on which the computer vision algorithms? So the computer vision person will say, well, it can't be me. And then you can say, okay, well, what about Volvo, the car company that Uber was using? And so Uber can say, well, we did something, but the car didn't respond, or and so the fingers start to point to each other. And then you come to the city regulators and the state regulators who allowed Uber to actually drive over here, and they say, well, we want to promote economics, growth, and business, because hey, China's going to do it. China's doing it much better than us, and they always give some argument, right? The politicians, and so they say, well, keep testing on our roads, but hopefully you don't screw up. So the question now is, who is really responsible? Like now, a person died on the street, right? I mean, it could be like a pedestrian like you and me crossing 34th and Walnut, and a self-driving car hits someone, God forbid. But then everybody starts to point fingers to somebody else and says, wasn't me, wasn't me. And that's the question we are trying to ask over here today is, where does this locus of responsibility lie in this kind of situation, right? And we want to differentiate this from the moral responsibility in terms of an ethical question that we are trying to ask over here versus a legal responsibility, right? I mean, we have these tort laws, and then when you go from like a human-driven car to a self-driving car, it switches to like a product liability, and then each jurisdiction, based on their precedents, will have some kind of a legal outcome as that, right? But we are not talking about what was the outcome of the Uber case. I will reveal that to you in a bit. But the question is, right now in this situation, who is morally responsible when a robot takes an action and that kills somebody, like that, right? So and in this case, the car is not trying to go and kill somebody, but it did end up killing someone, right? So it's not like its intention was to kill someone. But now let's think a little bit about that last statement, right? Why don't we take it to the extreme now, where we have an autonomous weapon system that's designed to kill people, but it actually now kills a human being that it wasn't supposed to kill. It is killing a civilian. And that's where this reading material that I shared with you all called Killer Robots over here comes in, where this author over here, Robert Sparrow, he presents this as, well, we are going to have these robot armies coming through. You're starting to see more of this autonomy in drone warfare of different sorts. But the question is now, if we take the situation where a robot has, now start to is killing, that is their choice. It's killing other, enemy combatants. But what if it kills an innocent person it was not supposed to kill, right? So first we need to understand what is the thesis, that Sparrow is developing in this paper. And here, the question is, well, when an autonomous system over here is actually, making a choice to actually have an action, say to kill a person, to shoot them, whether in, with whatever means, where is this locus of responsibility when it actually makes a decision that is not a decision that was fair or reasonable, or it was basically an innocent person that was killed. And They say, okay, well, let's see. It could be the programmer. The programmer had programmed the code for it to detect and say, this is the type of target. We need to go and attack this target with, 78%, accuracy or confidence, or 85% confidence. What does even 85 or 87% confidence mean in this case, right? Is that party an enemy combatant or not? But what's the difference between 85% confidence and 87 or 92%? I don't know. And I don't know how you can actually even come up with a scheme that says, well, 87% or more is good enough. Who sets that threshold? So the programmer is responsible, but the programmer would say, well, wasn't me, because I programmed this AI system. The AI system learns on its own, and it does online learning, and it keeps retraining itself, and it's making most of the decisions in this case. But I was hired in this position to program the system by my commanding officer. You should talk to him. The commanding officer says, look, I don't even know the P for Python over here. I don't know how they coded the system. I was given the mandate by Congress to build these systems to basically save our troops, and we don't want to kill our own troops. We don't want to kill our own people. So actually, this the programmer says wasn't me. Commanding officer says wasn't me. Commanding officer can't code, right? There's a benefit of saying that, right? And then they say, well, it's a machine. What about the machine, guys? The machine did the action. The machine was there. The machine pulled the trigger. Now you might say, well, that's ridiculous. So you're saying the machine is responsible? What are we going to do about that, right? So this is this argument that, well, there is this locus of responsibility, but it seems to be moving around. We can't actually pinpoint, where it is. And each of the stakeholders say, look at the next guy up there, right? So the first thing is, when we talk about these, killer robots within an ethical context, the first is to have this assumption that, that this system over here is actually has attacked, the enemy soldiers who have, say, clearly, expressed their desire to surrender, or like some journalists who were, in over there, and they've clearly marked their vehicle as press, and they're saying, look, we are not the enemy, for example, don't kill us, like that, right? So now the question here is, when this autonomous, weapon system, AWS, not the Amazon AWS, they are okay, but he has full knowledge of the situation and the likely consequences if it, makes a wrong choice, and it goes ahead with that, right? So it killed it maybe because it calculated the costs, of watching over them or keeping them as a prisoner were too high. Maybe it was to strike fear. Maybe it was to test the weapon systems. Maybe it was, I don't know, seeking revenge for the death of other robots that were destroyed in the battle. For whatever reason, the point is that it made this action, right? Which is very, very possible when we are in this situation, to kill innocent people, right? So let's take a step back and say, okay, well, we're talking about autonomous systems, but at what point, do we consider this system to be autonomous, right? I mean, if we say, oh, I'm going to pinpoint to you exactly that's the target, and then I'm going to even steer the gun to that point, and then you pull the trigger, machine, and the machine pulls the trigger, or is it the target finding and the pursuit of the target and the tracking, and then the attack on the target is done by the machine? Or it could be the whole end-to-end, just go out in the field, find all the targets, and, annihilate all of them, like that, right? Is it within this geographic zone? So autonomy is obviously along a spectrum over here. And, how much the human guide is there in, say, just programming the system, and what kind of fraction of this decision making is done by the autonomous system. That's obviously something to debate and argue, and to actually go through and find out from the system, right? But increasingly, we want systems to be end-to-end autonomous. That means we deploy them, they go on our behalf, or the military's behalf, And just for the record, I don't work on any DARPA projects that attack humans or anything like that, right? We work on very peaceful projects. Most of my research is actually on medical devices to save people from heart disease. But back to this argument here now, right? So the other thing is, okay, well, the military has this interest to have this, and there's going to be increasingly interest, right, over here, because first, you don't want to risk your own people's lives when you can send the machines in, right? So we don't want to have this political cost of, our friendly casualties also. And then it's also much cheaper, right? These piloted systems, they are intended to be replaced. But this represents like an implicit value system, that makes this political cost calculation that basically is saying something, right? It's saying that, we value our people much more than we value, say, the cost of making a mistake with casualties. But if you ask most of the people who design these systems, they say, well, it's all about precision. It's one shot, one kill, right? That was actually a keynote I heard where there was a 82-year-old general, and he said his whole life's mission was to get to one shot, one kill. And I was like, wow, that's pretty dark to have a life's mission at the age of 82 to say one shot, one kill. But in a sense, what he meant was, I don't want to kill, the people we don't want to kill, right? For whatever reason. Obviously, they want to be as precise. But here the question is, when we send in the machines, we are basically saying, well, obviously we value our people much more than, the enemy combatants and the civilians on the other side. And so whose lives must be protected if, say these AWSs over here are not, 100%, precise like that, right? So let's think about, like, now, when we think about self-driving cars, usually in this ethical argument, people bring up, like, this trolley problem and these hypothetical problems. But here we are talking about, a very specific problem. Say now, we get 500 new self-driving cars that the Philadelphia or the Pennsylvania government says we want to test them out now in Center City and West Philly and University City. But these self-driving cars that come in, they are being tested out live in the wild, and that's also one of the criticisms of, Elon Musk's sort of, let's deploy it and let's learn over time. And so the question then is, okay, well, whose lives must be protected in this calculation? You and me, we are pedestrians on 34th and Walnut, and we are if there are 500, cars that are driving around every day that are self-driving and not fully tested out or in testing in the wild, then we are at risk. The cars can crash. Nobody's going to get hurt in them because there's nobody in the car. But you and me driving around now have some, unreasonable and unnecessary risk that we need to face. And the government has said, well, we are willing to take that cost. But did they ask you or me? Maybe. I'm not that important yet, right? They didn't ask me yet. So the question then is, whose lives are we protecting? Are we protecting the rich folks who can buy these self-driving cars and, who come in from the suburbs into the city, for example? So we are always kind of, when this choice is being made, there's always like one group's interest is being advanced over the other. And so we are really looking at those kind of questions. And so when I asked just going back to dialogue, when we asked the engineering students, is it, fair to actually test in the wild? And on one hand, most of them say, yes, of course. Eventually self-driving cars will be much safer than human drivers, and we will save more people over the long term. I say, well, fair enough, good point. Technology is meant to be making our lives better and safer and more convenient. But if you're testing in the wild, then people will get hurt and people may die along the way, as we have seen in some of the Tesla cases. And is that a cost we're willing to take? I remember in one time when I was teaching this class, overwhelmingly, over 95% of the students in the class said, yes, it's a cost that is reasonable and they're willing to take. And then, of course, since I'm such an annoying, professor, I said, well, what if one of the people that dies is from your family, like your little brother or sister? Let's make it personal then, right? Then obviously nobody's going to put their hand up, you know, but that's the point. Like, okay, well, if it's an abstract problem and an abstract group, then it's fine, right? Testing in the wild. So, but coming back now from, autonomous vehicles is something that is, not designed to be a safe system, but that's what the intention is. It's not yet safe enough like that, right? We are still figuring it out. We'll be figuring it out for the next decade at least. So, but when you look at it with autonomous weapons, it's much more clear cut like that, right? So then the question is, who do you think it's important? Why do you think actually it's important to assign responsibility for that, right? So, and if you look at Sparrow's discussion, responsibility in, a just war is a requirement, because the party who is responsible for causing or inflicting pain or death on the other party has to own up to that, right? And that was actually established after the World War I and World War II. Otherwise, we would just treat each other indiscriminately and treat them like vermin, right? And have absolute no value for human life. But in a just war, like and the party that is responsible has to, own up like that and even declare prior to attack that, right? So now, does that happen in this case? Well, not really like that, right? So then the question then is, okay, well, how do we now start to, when we move from a killer robots case, which is designed to kill, to autonomous vehicles case, which is actually designed not to kill like that, right? But it does end up, causing, a human loss. Then, this transfer is what we are really discussing over here, that in the killer robots case, you have these stakeholders: the programmer, the commanding officer, the military complex, the politicians, the machine itself, all these. But we cannot find a locus of responsibility there. And similarly, in this case, for this like Uber accident, they could not find the locus, because first, let's go through the parties over here, right? So Uber says, well, we are not responsible because the pedestrian, first, this is actually what they said, the pedestrian was jaywalking and it's a pedestrian's fault. Then they realize that's a really, really bad PR decision, and also really stupid thing to say. So then they said, well, it's not our fault because it's Volvo's fault. And then Volvo was very quick to just tweet right away and say, well, you guys actually had disabled the automatic emergency braking system, because when you were testing your vehicle, it was jerking too much and the ride was making passengers a little sick and nauseous. So you'll actually disabled the automatic safe emergency braking system that would have triggered on Volvo's behalf. So Volvo says, wasn't me. And Uber is really trying to say it wasn't me. And the regulators say, well, okay, guys, we can't code. We don't even know what Python is, right? But we have a lot of Pythons in, Arizona. And then the question is, okay, well, in the end, the party that went to jail was actually the safety driver, because she's the least, politically powered party, and also the one that they could pinpoint and say, okay, well, this is a person. Luckily, the programmer also didn't, they tried to find, okay, which programmer could be responsible. And but of course, Uber's CEO, no problem, not a problem at all. They continued testing after a short break, and then it moves on, right? So, and this is the problem that we are trying to get to. So there's this tension, right? That we have this is good military reasons for, say, developing autonomous weapon systems, but then if you're not going to try to let them exercise their full autonomy, then what's the point, right? You want them to go to full autonomy. So same thing in Tesla's case, they want autopilot for reasons, and they have good reasons for bringing autonomy, these claims for, enhanced safety. And then they also promise to limit its use when they have less confidence. But, when does it do a handover to a driver? So in many cases, the Tesla has crashed into a wall, and then they say, well, we told the driver 15 minutes ago that they should they should take charge, but 15 minutes or 7 minutes or few minutes on a highway or on a road is a very different scenario from when it actually occurs, right? Or when in one case the Tesla car hit a wall and they said, well, 3 seconds before we told the person you need to take charge, but what about the momentum and this law of inertia of the car actually going and hitting the wall? And so these are the questions that we try to discuss. Now, do I have a clear-cut answer? Well, you can kind of know in which direction I'm biased in terms of being able to build provable systems in the technology side. But I think these kind of discussions are so important to have so that the engineers can at least have a ethical framework within which they can take this thinking, and sort of their managers say, well, you got to just deploy the system right now because quarterly results are coming up and we need to show this. So I'm getting pressure from above. Then the programmer's choice is there, but it's a tough choice. You're not going to oppose the manager and all the pressure you have inside the company. And then I'll let you sort of take this other argument because we are running over time on can we hold the machine responsible, right? I mean, it sounds really absurd, and actually the author over here does say we have to go to this absurd level, because if the machine can suffer and feel pain, then the machine is no longer like a machine, it's more like a human, and that defeats the purpose of building the machine. So by sort of showing through a counterintuitive way that the machine is not going to feel any pain, we cannot punish this machine, obviously. So that brings us back to as you now go through your studies and you become like decision makers and implementers and builders for making autonomous systems in this bright future that we have, we need to take this concept of what is this locus of responsibility in the systems we are designing? Where does it lie? How do we find it? How do we pinpoint when things go wrong? What's the chain of command? And where are we actually getting our truth over here, right? So so this is the questions that we try to answer as we do engineering in this here. And I'll be happy to take questions. Please feel free to email me, reach out anytime. Thank you very much.